Hi, thank you for joining us for this session of Functional Safety and AWS IoT. I am Syed Rehan and I'm a Senior IoT Developer Advocate within AWS IoT Service Team. So let's begin. So we will talk about the reason behind this series where I will be creating multiple videos with functional safety. We will look at what is functional safety. We will talk about functional safety in relation with IoT, and we will discuss pain points and developer feedback you can provide to us. So first of all, about this series, I'm going to be doing multitude of mini, small, uh, short videos talking about functional safety in general, and we will go through all of these its standards in a details where it's relevant with IoT. And we will in this video today we will talk about functional safety. We will talk about functional safety standards, and we will look at these standards, what they actually relate to: ISC 615, IEC 1615008, ISO 26262, Defense Standard, DO 178, IEC 62304, and 61511. So to start with, let's look at what is actually functional safety. Functional safety is actually the part of our overall safety of our system or a piece of equipment that depends on automatic protection operating correctly in response to its input or failure in a predictable manner. So the goal behind functional safety is to use functions to reduce the risk of equipment causing harm to human beings or people, or damage to a property or society due to malfunction of or incorrect operation of that certain component. For example, if you were to look at in IoT and robotics perspective, let's say if you're using a motor control device on robots, we basically want to make sure that the device the motoring device basically stops working the moment it basically comes in contact with the hazard. So for example, it basically detects a water seepage, and then it basically should stop to make sure without causing any impact to human being and causing destruction, such as resulting into a fire and whatnot. This is generally where the functional safety comes into perspective. So let's go through some of these standards. I will talk about in details IEC 61508. IEC in general, IEC 61508 is actually a main umbrella standard of functional safety. Then we have ISO 26262, which is actually an automotive functional safety in relation with automotives. Then we have Defense Standard 0056, which is effectively a Ministry of Defense Standard 0056. And basically, all it's about is mapping the risk of life associated with operation of the military systems, effectively. Then we have DO 178, which is effectively applies to aerospace and defense softwares. Then we have medical devices one, which is 62304. And then we also have process industry sector in an industrial environment, which is 61511. We also have CE, which is effectively a manufacturing marking for functional safety. So you are required to, if you're selling an electronic product, the CE marking is required for all the products to show the manufacturer has actually checked these products meet EU safety criteria, health or environmental requirements. It basically linked with this standard. Then we also have BSI IoT. It is one of the new standards. It specifically comes into effect a couple of years ago, and I recently worked with one of the customers who basically had their devices certified as BSI IoT devices. It goes through various checkpoints and checks to make sure it meets the criteria, and it effectively applies to BSI standard into UK, but generally is acceptable all across the world. Okay, so let's look at what is actually IEC 61508. So as I mentioned earlier, IEC 61508 is effectively the main standard. The rest of the standards are derived from it. So it comes, it effectively, if you look at it, it is actually a consensus standard of many different countries distilling down into one standard where they actually agree to it, where they want to make sure this is an acceptable standard all across the globe. So this is where from a US perspective is ISA S84 was distilled into it. From a UK perspective, HSC PES was distilled into it. European perspective was EWICS. And similarly, with from a Germany perspective, was DIN V 19250 and DIN V VDE 0801 distilled into it. All of these consensus standard was basically derived as IEC 61508. So if you were to talk about how 61508 actually works, there are actually three levels. First one is safety integrity level, which is, if you were to think about it, it's a discrete level for specifying the safety integrity requirement of the safety instrumented functions to be allocated to safety instrumented systems. And then we have a layer above that, which is safety instrument function with a specified SIL, which is in this case safety integrity level, which is necessary to achieve functional safety. So a set of equipment used to achieve an automatic protection function. It is basically distilled down to a functional level. This is where we have SIF. Then we have SIS, which is safety instrumented system. This is a bigger picture. Instrumented system used to implement one or more safety instrumented functions. And SIS is composed of any combination of sensors, logic solvers, final elements, and all of this is combined. So starting from bottom up, so we have SIL, which is safety integrity level. Then we have SIF, which is basically encompassing many SILs. And then we have finally safety instrumented system, which accompany many SIF and SIL within it, and it's basically implementing one or more safety instrumented functions within it. So the role of IoT within IEC 61508 is varies, and it basically differs from industry to industry. We can basically look at manufacturing, we can look at our aerospace, we can look at safety softwares, we can look at railway applications. So the list is huge, and the safety standard comes into effect. The point is that we need to make sure each individual industry is aligned to it. And within this series, we will look at each one of them in the details where they are mapping to IoT in perspective or IoT in relation. So for example, ISO 26262 is effectively related with automotive. So we could basically be looking at the details in terms of how basically this can impact a connected vehicle, where we basically can a data coming in from ISO 26262 coming into the cloud, and what you can basically do about it. So with that, let's talk about the regular developer pain points. So having spoken with quite a lot of developers, the feedback generally I got from developer is always really difficult to certify your software to meet many criteria. So for example, you have many segregated certification organization, right? And you have variety of standards applied for a single device. For example, you may have a car which basically has a certain standard when it comes to automotive. It has a certain standard for functional safety. It may also be having certain standard applied to it if the same equipment, for example, the ECU, electronic control unit in the car, is basically used, let's say in a truck, or if it's used in a van. Because the change of the automotive has differed, because the fact is that it's not a car, carrying just human beings. It basically are carrying for example, a truck carrying a cargo load. It basically has a multiple different certification applies to it. This is where one of the pain points developer told me is that we have to basically look at each individual vertical of the industry and apply for based on each individual device criteria. So for example, if you're reusing a certain electronic components from a functional safety perspective, you need to apply those theory to make sure it is applicable to multitude of industries. And also the pain points comes about saying that how can you basically certify across a multitude of organizations to achieve this standard. For example, from automotive ISO 262, then we also have from IEC 61511, where we basically might look at the same component being used in industrial sector and so on. And then also you need to be, the developers needs to concerned about that how can we make sure that the existing certified software can be reused for certain software without actually impacting the previous criteria which has actually passed. So if you basically has achieved ISO 26262, then you want to make sure that IEC 61511 doesn't basically when you're making any changes to meet the criteria, you do not actually break the achievable or certified criteria of the previous standard. So finally, coming back to developer feedback, how you can basically provide feedback to us in terms of your experience, your pain point, how we can basically take your feedback and improve you to achieve certain criteria easily from AWS IoT perspective. So reach out to us on youtube.com/IoT Builders stream, which we do it every week, or on Twitter or on LinkedIn. So with that, I'll conclude this section of this video. Thank you very much for watching. Subscribe for more and connect with me if you have any questions. Thank you very much.